S1. They are separated by distance lambda by 3. And let me keep a detector far away where that the distance x will be very much greater than lambda. All source, their coherent sources S1, S2, S3 are coherent sources. They'll vibrate together. They're separated by this one. I want the intensity at point P. S1, S2 are coherent sources, and let I not be the intensity at point P individually due to each source. Find the resultant intensity at point P. The detector is far away from the source here. Find the resultant intensity at point P detected by detector. Okay, there's a very good question. Again, we are discussing interference of more than two sources. Is it okay? So we have three sources are there. What will happen to waves? So let me take the S2 as reference. So which wave will cover more path? The wave generated by third source. So now all the waves are generated. So these waves, what happen, will propagate. This will propagate some distance. This will propagate. This will propagate. Is there any path difference between the waves when they arrive at point P? As compared to all, this will cover more path, no? Than this. If this covers a distance x, how much of more path the wave 2 will cover? Lambda by 3. How much of more path compared to 1 this will cover? 2 lambda by 3. So is there any path difference between the waves arriving here? Yes, there's a path difference due to that phase difference. So how to calculate the resultant intensity? We did maximum this for two or source of that one. More than two sources, if it comes, what to do? So what we do is like, let me take this as reference, this particular thing as reference. Compared to wave 2, how much of more path the wave 3 will cover? Phase difference of 3 with respect to 2. Should go to 2 pi by lambda. What is lambda? Wavelength of the waves. Let lambda be the waves emitted by the sources. Okay, this one. So this is what is the path difference between them? Shall I put lambda by 3? So 2 pi by 3 is what we are getting. Similarly, path difference of the wave 1 with respect to 2. 2 pi by lambda. Can you ask, sir, why minus 2 pi by 3? This will have more path compared to 2. This will have less path. So if I take this is 0 phase, this will lead, this will lag, no? Less path. Compared to wave 2, this will cover more distance. How much? Lambda by 3. Compared to wave 2, this will cover less distance. So this will be leading, this will be lagging, that one. Okay, now let me take this as a reference. So I'll go for phasor diagram. In the phasor diagram, what we have is, I think this was the method we have suggested, no? Superposition. So the first, so there's a blue color, no? So the amplitude of that E. Uh, what about the wave 3? It will lead by how much of phase angle? 2 pi. 2 pi by 3 should be 120. Is it okay? then the wave one will lag how much? Minus 120 degrees. Minus 120 degrees. Is it clear? So this should be how much? 120 degrees. So this is a one. This is amplitude. All will have same amplitude. All they are having intensity I naught to be same. So this is a wave one. This is a wave two. This is a wave three. This is a wave one. Now, what is the resultant amplitude at point P? Shall we write A plus A minus of A cos 60 plus A cos 60? Look at once. How much here? This will be 120, this 30, this will be 60, no? So this angle will be how much? 60 degrees. So why you are subtracting? Why you are subtracting? If this vector is along x-axis, how is this vector component of it along x-axis? A cos 60, A cos 60, I'm adding up. So this will become, so what is happening finally? AR is 0. Then resultant intensity at point P is 0. Means even if there are 3 loudspeakers are there, what happen? You are unable to hear anything. The reason for that, because the loudspeakers are coherent and they're separated. So I'll increase the volume of this. Still you are unable to hear anything. Okay, I think this is more dangerous, no? This will be more dangerous. Sir, I'll change the distance to lambda by 6. Okay, try it. Try this one, or we'll have a discussion now only. We'll wind up the thing. No? We'll take one more case so that you'll understand what actually we are discussing it. Huh? Instead of lambda by 3, let me make lambda by 6. And tell me where you are going to make changes now. This will be lambda by 6. So this will become pi by 3. This will be minus lambda by 6. So this will become minus pi by 3. Is it okay? Fine. So then we'll draw the phasor diagram. And the phasor diagram, compared to the wave one is blue color. Pi by 3 means how much it is? Pi by 3. Pi by 3 means it is 60 degrees. Where is the wave? This will be, and the other one will be here. So this will be 60 degrees. Amplitude all are of same. This is 1, 3, and this is 2. What is the resultant amplitude? A plus 2A cos 60. Then how much it will become? A or 2A. What is the resultant intensity will be? IR is equal to AR whole square will be 4A square. And we know I naught is equal to A square. This was the assumption. So how much intensity will be? 4 I naught. Okay, this is better, no? So I think if you have 3 loudspeakers and if they are positioned, if the separation between loudspeakers is how much lambda by 3, you're not going to hear anything. This is more dangerous. If they are separated by distance lambda by 6, yes, you are going to hear. If they're separated by distance lambda, tell me how much the intensity here will be. Anybody wants to answer? Resultant intensity at point P. Anybody? If the separation is lambda, if the separation is lambda, then phase angle how much will become 2 pi, 2 pi. Then a plus a plus a, 3a, squaring of that 9, 9 I naught, I'll get maximum intensity. So the loudspeakers, if they have become coherent, this is a big headache. So what shall I do? Shall make them incoherent? If I make incoherent, tell me what is the advantage? I need not to bother the distances here, no? What is the intensity at this point? I naught, I naught, 3 I naught. I'll be safer, no? If they're coherent, I should be very specific about the distances. If they're separated by distance lambda, then I'll get maximum 9 I naught. If they're separated by lambda 3, I'll get 0. That's why the loudspeakers must be incoherent only. We'll be on safer side. Okay, let me end up the class. Huh? I have to go to college. Okay, thank you all of you.
Thank you, sir.
Okay, I'll end up the class. Okay, thank you all of you. Yeah.